friends, I am a chemistry faculty from QLS Academy. Today we will try to understand, is matter around us pure? I hope you will enjoy today's learning. Let's start with our today's topic, is matter around us pure? What do you understand by purity of a substance? We can see labels of many products stating pure ghee, pure honey, pure milk. And for a layman, प्योर सब्सटेंस मीन्स अ सब्सटेंस विदाउट अडल्ट्रेशन, बिना मिलावट की चीज़ों को हम प्योर कहते हैं. पर एक साइंटिफिक पर्सन के लिए प्योरिटी का मतलब थोड़ा सा अलग होता है. फॉर अ कॉमन मैन, प्योर मिल्क में सिर्फ मिल्क ही होना चाहिए, नथिंग एल्स. प्योर हनी मीन्स ओनली हनी एंड नो एडेड शुगर. But for a scientist, a pure substance should have particles of same kind only, or we can say that the substance should have only one constituent. These particles which make up a substance are called atom, or in other words, atoms are the building blocks of any matter in the entire universe. Now, the confusion arises. How such tiny atoms make up great things? इतने छोटे छोटे जो atoms होते हैं वो इतनी बड़ी चीज़ें कैसे बना लेते हैं? It is just like building a house. In a house, bricks can be denoted as atoms. Atoms combine to form a molecule and molecules combine to form matter. Atoms मिलके molecule बनाते हैं, molecules मिलके matter बनाते हैं. We know that matter on the basis of its physical nature is basically of three types, that is solid, liquid and gas. The other two states, plasma and Bose-Einstein condensate, are not naturally found on Earth. Matter on the basis of their constituent atoms can also be classified as pure and impure. Pure substances have atoms or molecules of only one type. जो pure चीज़ें होती है उसमें सिर्फ एक ही तरह का atom या molecule present होता है. While impure substances have atoms of different varieties and are called mixtures. So, in a line, mixtures are impure matter formed by mixing atoms or molecules of two or more types and in different proportions. Most of the things around us are mixtures, means they are made up of different particles. Sea water, air and coin are all mixtures. But you can see that all of them are different states. इन सभी का जो physical nature है वो vary करता है एक दूसरे से. Sea water is liquid while air is gaseous and coin is solid. So based on the different physical nature of the components, mixtures are further classified as homogeneous mixtures and heterogeneous mixtures. Now, first, homogeneous mixtures. A mixture is said to be homogeneous when all the components are uniformly mixed and no distinct boundaries of separation could be observed among them. For example, seawater, alloys, which is mixture of different metals, and lemonade. In general terminology, homogeneous mixtures are also called solution. Generally, homogeneous mixtures को हम solution भी कहते हैं. But usually जब हम solution शब्द सुनते हैं हमारे दिमाग में एक liquid matter की इमेज आती है. We imagine solution to be something liquid, but it is not true. Every homogeneous mixture is a solution. Sugar solution and iodine tincture are both solid in liquid mixture. Alloys are solid in solid mixtures of metals. Mixtures are not limited to solids and liquids only. Air is also a mixture. It is a mixture of different gases like oxygen, carbon dioxide, nitrogen, etc. There are two major components of a solution. The component present in larger amount to dissolve the other component is called solvent, while the component which is dissolved in the solvent is called solute. Usually, the quantity of solute is lesser than solvent. Now, let's make sugar water, which is just simple sugar solution in water. हम एक glass पानी लेंगे and to it we will add a spoonful of sugar. हम इसमें एक spoon sugar add करेंगे. Now we will stir it until all the sugar gets dissolved. अब हम इसमें एक spoon sugar और add करेंगे. Have this extra sugar dissolved in water? हमने जो second spoon of sugar add किया, क्या ये dissolve हो गया है? Yes, the second spoon of sugar has also got dissolved in water. Now, try to dissolve 1 more spoon sugar. Have it dissolved? No. No, the third spoon of sugar didn't dissolve. You must be thinking, why did this happen? Sugar तो water में soluble होती है, फिर भी dissolve क्यों नहीं हुआ? It is because a glass of water has a maximum capacity to dissolve sugar in it. हर चीज़ की एक मैक्सिमम लिमिट होती है, लाइक हम एक दिन में 2 घंटे पढ़ सकते हैं, बट दिस मैक्सिमम लिमिट कैन बी स्ट्रेच्ड. इस मैक्सिमम लिमिट को बढ़ाया जा सकता है, लाइक इन एग्जाम टाइम. एग्जाम टाइम में हमारे पास बहुत प्रेशर होता है, हमारे ऊपर बहुत प्रेशर होता है, हमें केमिस्ट्री भी पढ़ना है, हमें फिजिक्स भी पढ़ना है, मैथ्स भी पढ़ना है, सोशल भी पढ़ना है, हमें सारी चीज़ें पढ़नी होती है एट द सेम टाइम. सो ड्यूरिंग एग्जाम टाइम, instead of studying for regular 2 hours, we start to study for 4 hours, 5 hours and maybe 6 hours. Similarly, the maximum capacity or limit of a glass of water to dissolve sugar in it can be increased by heating the water. When we heat a glass of water, instead of dissolving 2 spoons of sugar, water can now dissolve 4 or 5 spoons of sugar. The taste of sugar water and sugar syrup varies greatly, though both of them have same components, sugar and water. दोनों को ही एक ही सिंगल ग्लास ऑफ वाटर में बनाया गया है, but the quantity of sugar is different in both. Syrup is loaded with sugar, while sugar water or sugar solution has very less sugar. So, based on the quantity of sugar in each solution, we can call them either dilute or concentrated. Syrup have too much of sugar and hence is called concentrated sugar solution, while sugar water have lesser amount of sugar and hence is called dilute sugar solution. जिसमें ज़्यादा होगा उसे हम concentrated बोलेंगे और जिसमें कम amount होगा उसको हम dilute बोलेंगे. Here we can see that there is a significant difference in the concentration of sugar in both the solutions. Concentration. So, here we have a new term, concentration. Concentration is the ratio of solute in a solution to either solvent or total solution. हम इसे कैसे calculate करेंगे? Concentration of a solution is equal to amount of solute divided by amount of solution. Based on the concentration of a solution at a given temperature, solutions can be graded as saturated, unsaturated and supersaturated. When no more solute can be added to a solution at a given temperature, then the solution is called as a saturated solution. The sugar solution at step 2, where 2 spoons of sugar were added in water, is an example of saturated solution. A saturated solution have the maximum concentration of solute in it. The amount of solute present in the solution at this point is called its solubility at that particular temperature. किसी भी एक पर्टिकुलर टेम्परेचर पे किसी भी सोल्यूशन में जितना मैक्सिमम अमाउंट सॉल्यूट प्रेजेंट होगा वो उस सोल्यूशन या सॉल्वेंट में उस सॉल्यूट की सॉल्युबिलिटी कहलाती है. A solution which still have a chance to solubilize more solute is called an unsaturated solution. ऐसा solution जिसमें अभी भी और solute मिलाया जा सकता है उसे हम कहते हैं unsaturated solution. The sugar solution at step 1 with only 1 spoon of sugar was an unsaturated solution. We have seen that upon heating more sugar can be dissolved in a glass of water. From it, we can infer that the solubility increases with increase in temperature. जैसे जैसे हम temperature increase करते हैं solution का, उसकी solubility भी बढ़ती जाती है. A solution that contains more solute than the solvent can dissolve under normal conditions is known as a supersaturated solution. Sugar syrup is a supersaturated solution. Supersaturated solutions are not stable, and after some time the extra solute particles dissolved by heating sediments out, and in this case, in the case of sugar solution, the sugar particles will recrystallize. Now, till now we have saw types of solution based on concentration. Now, how can we find this concentration? हम concentration को calculate कैसे करेंगे? The solute concentration can be expressed as mass percentage or as volume percentage. It is just like calculating your percentage after every exam. The mass by mass percentage of a solution is calculated by mass of solute divided by mass of solution multiplied by 100. And the mass by volume percentage of a solution is calculated by mass of solute divided by volume of solution multiplied by 100. Generally, the mass by mass percentage is thought to be more accurate because the volume of a solution is also affected by other factors like density of solute and solvent. You will be studying this in higher classes. अब तक हमने homogeneous mixture means solutions के बारे में पढ़ा. Now we are going to talk about heterogeneous mixtures. A mixture is said to be heterogeneous when all the components are not thoroughly mixed and there are visible boundaries of separation among them. For example, milk, smoke, salt and pepper, etc. Heterogeneous mixtures are further classified as suspension and colloid. So first we are going to talk about suspension. A suspension is a mixture of two substances, one of which is finely divided and dispersed in the other one. Just like solution, a suspension also have two components, a dispersion medium which is equivalent to solvent in solution and the dispersed phase which is equivalent to solute in solutions. An example of suspension is muddy water. Now, colloid. A colloid is a type of mixture which is intermediate between solution and suspension. Its properties are also intermediate between the two. Milk, fog, smoke, colored gemstones are all examples of colloid. Colloids also have two components same as suspension, a dispersion medium and a dispersed phase. So depending on dispersion medium and dispersed phase, colloids can be of various types. First one is emulsion, which is liquid in liquid colloid. इसमें dispersion medium और dispersed phase दोनों ही liquid है. Milk, creams, ointments are all emulsions. The second type of colloid is sol, which is solid in liquid colloid. Milk of magnesia and mud are both sols. Notice that mud is a colloid. जो mud होता है वो colloid है and muddy water जो है वो suspension है. Another type of colloid is aerosol, where gas is the dispersion medium. Solid in gas and liquid in gas sols are both aerosols. Another type of colloid is aerosol, where gas is the dispersion medium. इसमें जो dispersion medium है वो gas है and dispersed phase could be both solid or liquid. So, solid in gas and liquid in gas sols are called aerosols. Fog, clouds, smokes are all aerosols. It is not always necessary to have a fluid, liquid or gas as dispersion medium. ज़रूरी नहीं है कि जो dispersion medium है वो हमेशा कोई fluid हो. Means हमेशा liquid या gas का होना ही ज़रूरी नहीं है. Solids can also play the role of dispersion medium. Colored gemstones are colored because of solid impurities trapped inside a solid stone. So, solid in solid colloids are termed as solid sols. Now, how can we distinguish among different mixtures? हम कैसे बता सकते हैं कि ये solution है, ये suspension है, ये colloid है? How? Mixtures can be differentiated on the basis of their properties like particle size, distribution of particles, sedimentation rate of solute particles and scattering of light. The particles of solution are the smallest with diameter less than 1 nanometer, that is less than 10 raised to power minus 9 centimeter. The particles of colloid are of diameter 10 raised to power minus 7 centimeter. The particles of suspension are the largest with particle size more than 10 raised to power minus 5 centimeter. The particles of a solution are not visible through naked eyes. They are so small they can't be even seen under a microscope. Solution के particles इतने छोटे होते हैं कि हम उन्हें microscope के नीचे भी नहीं देख सकते हैं. The particles of colloid are also not visible to naked eyes. Colloids के particle को भी हम naked eyes से नहीं देख सकते, but they can be easily seen under a microscope. While The particles of suspension are big enough to be seen through naked eyes. The next property is the uniformity of the particles. The particles in solutions and colloids are uniformly distributed, while particles of suspension are unevenly distributed. Due to the bigger size of the particles in suspension, the particles settle down when left undisturbed. This property of settling down of particles is known as sedimentation. जो सस्पेंशन के पार्टिकल्स होते हैं वो जल्दी से जल्दी सेडिमेंट हो जाते हैं, बट सॉल्यूशन एंड कोलॉइड्स के केस में ऐसा नहीं होता है. ऑल्सो because of the bigger size of the particles of the suspension, the particles of suspension can be easily separated out just by filtration. जो सस्पेंशन के पार्टिकल्स है हम उन्हें फिल्ट्रेशन के थ्रू सेपरेट आउट कर सकते हैं. While separation of colloid and solution particles is difficult. Particles of colloid and suspension can be separated by special separation techniques like centrifugation, evaporation, chromatography, etc. The next and very important property is the capability of the particles to scatter light, which is scattering of light. Light एक straight line में travel करती है until and unless there is some object in its path to deviate it. When a beam of light collides to any object, it can reflect, refract or simply light scatters. The scattering of light when a light beam passes through a colloid is termed as Tyndall effect. This effect is termed Tyndall effect in honor of John Tyndall, the scientist who first discovered it. Notice that I said when a light beam passes through a colloid. Why colloid? Keep this question, I will be answering it in a while. In our daily life, we can see Tyndall effect when light enters in a dark room. एक dark room है, उसमें से खिड़की में से एक थोड़ी सी light आ रही है. What does that happen? Air में present dust particles light को scatter करते हैं. The fog lights of car also show Tyndall effect. The light from fog light gets scattered by the water vapors of fog. इसी scattering की वजह से हम dense fog में भी सामने से आती हुई कार को देख पाते हैं. Scattering of light is not caused by any particle. Remember the definition of Tyndall effect? Scattering of beam of light when it passes through a colloid. Now your answer. Why I said colloid and not solution? It is because of the particle size of the colloid particles. The particle size of colloids and suspension are good enough to scatter light, but particles of solution are too small to scatter light. Hence, we can't see the path of light when it travels through a solution. So friends, let's recall what we have studied today. First, we understood the term purity. We learned about mixtures and its types. We learned to differentiate different mixtures. We also saw some new terms like atoms, molecules, concentration and Tyndall effect. We will discuss these terms in detail in next chapters and also in higher classes. Hope you enjoyed today's learning. For further information or you have any query, you can go to the following link. Thank you.